Hope you all are doing good. My name is Amrita Davis, working as Assistant Professor in Chemistry, Christ College of Engineering, Iringalakura. This is my second video. Hope you all gone through my last video. Like the previous one, we are back again with another video, mainly focusing on KEAM 2015 Paper 1 Chemistry. So without wasting our time, let's start our discussion. Our first question is the number of electron with azimuthal quantum number L is equal to 1 and L is equal to 2 for chromium in ground state are respectively. We have 5 options. Option A 16, 5, 16 and 5. Option B 16, 4. Option C 12, 4. Option D 16, 3 and option E 12, 5. So what will be the answer? Our answer is answer E. In order to solve this question, you should know what is the electronic configuration of chromium. As we all know, chromium shows an exceptional electronic configuration from other. That is, chromium with atomic number 24. So how we will write its configuration? 1s2, 2s2, 2p6, 3s2, 3p6. After 3p6, electronic configuration based on energy, it comes 4s1, then 3d5. Okay. In the case of chromium, 4s1 and 3d5 are half filled. So in order to attain stability, in order to maintain the unpaired electron same both in s orbital and d orbital, it is filled as 4s1 3d5, not as 4s2 3d4. Okay, so this is the electronic configuration of chromium. Remember, chromium is an exceptional case. It is not filled like 4s2 3d4. Okay, but 3p6, after 3p6, 4s1, 3d5. Then, what is an azimuthal quantum number? We know that L is represented azimuthal quantum number, and from L value we can understand the shape of the orbital. That is, if the value of L is equal to 0, shape of orbital will be S. It will be S orbital. If the value of L is equal to 1, then it will be P orbital. If the value of L is equal to 2, then it will be D orbital. L is equal to 3, then it is F orbital. So from value of L, that is from azimuthal quantum number, we can determine the shape of the orbital S, P, D, F. 0, 1, 2, 3 respectively. Okay. So in our question, it is given that the L value, calculate the number of electron present in the value of L equal to 1 and L equal to 2. So L equal to 1 means it is P orbital. So how many electrons are present in P orbital? That is, here 2p6 as well as 3p6, total 12 electron. Similarly, how many electrons are present in L equal to 2? L equal to 2, it is D orbital. So chromium, in the case of d orbital is half filled. It is an exceptional case in case of chromium. So how many electrons are present in d orbital? That is L equal to 2, 5 electrons. So answer is answer E, that is 12, 5. P orbital contains 12 electrons. Next question, d orbital. Question number 2, 5 electron. An odd electron molecule among the following is option A CO, option B SO2, option C carbon dioxide, option D NO, option E OF2. Here the answer is the odd electron molecule. The answer is very clear. In order to find the odd number of electron, first calculate the total number of electron in each case. So total number of electron in CO. How we will calculate the total number of electron? By adding number of electron in carbon and oxygen. That is, adding atomic number of carbon and oxygen. That is 6 plus 8. Total 14. Similarly, total number of electron in SO2. So it's equal to sulfur atomic number 16. Atomic number of sulfur is 16. Its molecular mass is 32. Atomic number 16. Only 16 electron in an atom. Oxygen, there are 2 oxygens. So 2 into 8. So altogether 32. Third one, CO2. Carbon 6 plus 2 into 8. 2 oxygens. Altogether 22. NO, that is nitrogen, atomic number 7 plus 8. Altogether 15. OF2, that is atomic number oxygen 8 plus 2 into 9 is equal to 26. So from this result, total number of electron, which one will be the odd value, odd total number of electron for NO? So NO is the answer. Molecule contain odd number of electron. So odd number of electron is for NO. Other CO, SO2, CO2 and OF2 contain even values, even total number of electrons. So answer is answer D, 15 for NO. So next question, question number 3. Which of the following changes in the respective bond order values are caused by removal of an electron from N2 and F2 molecule? What will happen to the bond order when one electron is removed from N2 and F2? Option A, decreased by 0.5 in both, that is in both N2 and F2. Option B, increased by 0.5 in both N2 and F2. Option C, increased by 0.5 in the former, that is N2, and decrease by 0.5 in the later, that is F2. Option D, decrease by 0.5 in the former N2 and increase by 0.5 in the later, that is F2. And for last option, no change in both N2 and F2. So what will be the answer? Answer is answer D. So we already discussed some questions from which is related to bond order in our last video. Likewise, in order to find the answer, we have to find the total number of electron both in N2 and F2. And from this total number of electron, we can calculate its bond order. Then we can check what will happen to the bond order when one electron is removed from both N2 and F2. So total number of electron N2, which is equal to 7 into 2, that is 2 nitrogens. Atomic number of nitrogen is 7, so 14. And F2, 9 into 2, that is atomic number of fluorine is 9. 9 into 2, 18. So 14 electron for nitrogen, 18 electron for fluorine. So what will be the bond order? We already mentioned one table, that is from number of electron we can remember its bond order from this table. If number of electron is 4, then bond order is 3. Okay. So total number of electron for nitrogen 14. So what will be its bond order? 3. Then total number of electron F2, which is equal to 18. So what will be the bond order of F2? 18. Its bond order is 1. Then what will happen? Our question is what will happen when one electron is removed from both N2 and F2? That is, if one electron is removed from N2, its total number of electron becomes 13. If one electron is removed from F2, its total number of electron becomes 17. So what will happen to its bond order? If total number of electron is 13, then what will happen to its bond order? Bond order decrease by 0.5. That is 3 changes into 2.5. Decrease by 0.5. Then what will happen to fluorine when one electron is removed? Its total number of electron becomes 17. Total number of electron becomes 17. So its bond order changes, or it is increased by 0.5. 1 become 1.5. Increased by 0.5. So our answer is answer D, that is bond order of nitrogen decreased by 0.5 and bond order of fluorine is increased by. Question number 4. Okay, the hybridized state of bromine in bromine pentafluoride is, we have five options. Option A sp3d, option B dsp3, option C d2sp3, option D sp3d, option E sp3d2. Our answer is answer E. How we will reach into this answer? We already discussed in our last video, that is, in order to find the hybridization, we have an equation, that is Z is equal to the value of Z. Z is equal to half into number of valence electron in the main atom. Here the main atom is Br, bromine pentafluoride. So bromine is the main atom. And what will be the valence number of electron? How we will find the valence number of electron? For that we should know the electronic configuration of bromine, and in the last shell how many electrons are occupied. In the case of bromine it is 3d10 4s2 4p6. So number of valence electron in the outermost shell, fourth shell, that is it contains 2 orbital s and p. Fourth shell contains 5 plus 2, that is total number of valence electron equal to 7. Then add if there is a negative charge, subtract if there is a positive charge, plus number of add the value, total number of monovalent atom, valency 1, atoms with valency 1. In the case of bromine pentafluoride, there are 5 fluorines. Fluorine is a monovalent atom. So substitute the values in the equation and find the value of Z. If you substitute Z is equal to, if the value of Z become 2, it is sp hybridized. If the value of Z is equal to 3, it is sp2. If the value of Z is equal to 4, it is sp3. If 5, sp3d, 6, sp3d2, 7, sp3d3. Then calculate the value of Z using the equation. Half into total number of valence electron in the main atom, that is bromine, it is 2 plus 5, that is 7. There is no negative charge, there is no positive charge, but there are 5 fluorine atoms, that is 5 monovalent atom. Fluorine is a monovalent atom. So half into 7 plus 5, we will get 6. So if value of Z is equal to 6, remember this table. If the value of Z is equal to 6, then it is sp3d2. So bromine pentafluoride have the sp3d2 configuration. Question number 5, answer E. Standard electrode potential of zinc and nickel are respectively minus 0.76 volt and minus 0.25 volt. Then the standard EMF of the spontaneous cell by coupling these under standard conditions. Okay, so standard potential value for zinc and nickel, E0 value for zinc and nickel is already given. It is a question from electrochemistry part. Okay, and it is the question is to calculate the standard EMF, that is E0 cell. We have 5 options. Option A plus 1.01 volt, option B minus 0.51 volt, option C plus 0.82 volt, option D plus 0.25 volt, option E plus 0.51 volt. Option so what will be the answer? It is a direct substitution equation. It's a very simple. That is, we know one equation for E0 cell, that is standard EMF of a cell, E0 cell, which is equal to E0 cathode minus E0 anode. Also, we should know in a cell which one become anode and which one become cathode. Anode and cathode can be determined using electrochemical series. All of you might have heard about electrochemical series. According to electrochemical series, anode is a metal with low reduction potential and cathode is a metal with high reduction potential. If two metals are present, then how we will find the anode and cathode? Check their electrode reduction potential value. Low reduction potential value become anode and high reduction potential value metal become cathode. So zinc with electrode potential minus 0.76 and nickel with minus 0.25. So zinc having the low reduction potential, zinc acting as anode, and nickel have high reduction potential compared to zinc, so it acts as cathode. Substitute their values in cathode and anode. So cathode, E0 cathode is electrode potential for nickel, E0 anode is electrode potential for zinc. Okay, substitute their values. E0 cell is equal to E0 cathode nickel minus E0 anode zinc. Substitute their values, minus 0.25 minus 0.76. Okay, so answer is 0.51 volt. Question number 6 plus 0.51
one
volt.
interesting question.
An organic compound contains 90% carbon
by substituting
10% hydrogen by mass. Its empirical formula. We should know what will be anode. Option A C2H4 electrochemical series. C3H6. Okay? Option C C3H8. Option D C3H4. Option E C2H6.
Our answer
So what will be
is
its
answer
empirical formula?
D.
It's given that 90%
So,
carbon
our
and
question
10%
is to find the empirical
hydrogen
formula. What is the
present
empirical
in our
formula?
molecule.
Empirical formula, it is the simplest or shortest positive integer ratio of atoms present in a compound. Now our question is given that our atoms present in our compound is carbon and hydrogen. So what is the simplest positive integer ratio between carbon and hydrogen in our compound? That is we have to find out. Okay. So it is given that 90% carbon and 10% hydrogen is present, which means 90 gram carbon and 10 gram hydrogen is present in 100 gram total solution. Percentage means 90 gram in 100 gram carbon, 10% means 10 gram in 100 gram solution. Okay. Then how we will find this empirical formula? There is a method that you have to remember. Okay. So we have two atoms in our molecule. It is carbon and hydrogen. It is given in our problem. Okay, carbon, how many grams of carbon? 90%, so 90 gram. Consider. Then hydrogen 10 gram. Then first we have to do, that is divide this gram weight mass given with molecular mass of carbon. Molecular mass of carbon is 12. So 90 by 12, which is 7.5. Similarly, divide the molecular mass, divide using molecular mass of hydrogen. 10 gram by molecular mass of hydrogen 1. 10 by 1, it is 1. Then next step, from these two values 7.5 and 10, which one is the smallest value? 7.5. So select the smallest value between these two and divide the smallest value with this value, carbon and hydrogen. So 7.5 divided by 7.5. Here also 10, value is 10. So 10 divided by smallest value between these two, that is 7.5. 10 divided by 7.5. 7.5 divided by 7.5. Okay. So here we will get which is equal to 1. Here we will get it is equal to 1.33. Next one, we have to calculate one integer form. So here it is 1, here it is 1.33. So in order to convert it into a integer form, multiplied, here we are going to multiply this with 3. So 1 into 3, then it become 3. 1.33 into 3, then it become 3.9. That is approximately equal to 4. So this is our empirical formula. Carbon, it contains 3 and hydrogen, it is 4. That is C3H4 is our answer. So this is the method to calculate empirical formula. First consider the gram weight from percentage, then divide the gram weight of each atom with the molecular mass. Select a smallest number between two or between the atoms, then divide that smallest number and convert into integer by multiplying with a number. So here in the case of carbon it is 3,
hydrogen, it is 4. So what will be the empirical formula? Directly we can write C3H4.
Okay, question number 7. Next one,
so
question number 7.
Answer D.
Which one of the following is an allylic halide? Option A, 2-chlorobutane. Option B, chloroethene. Option C, 3-bromopropene. Option D, 2-chlorotoluene. Option E, dichloromethyl. Answer is answer C. That is, we have to find out the allylic halide. Okay. So allylic group, we should know what is a allylic group. Allylic group means this group CH2 double bond CH single bond CH2. Okay. This group is known as allylic group. And what will be the allylic halide? An halide contain a allylic group, that is CH2 double bond CH single bond CH2X. Among the following 5 options, only 3-bromopropene contains an allylic group, that is 3-bromopropene having the structure CH2 double bond CH single bond CH2Br. So it is similar to an allylic halide. So both allylic halide, this structure, it is connected to allylic group, contain an allylic alkyl group and an halogen. Okay, CH2 double bond CH CH2Br. So answer is option C, 3-bromo. Question number 8.
Which contain
out of the following isomeric alcohol contains 5 carbon atom. The alcohol that exhibit optical isomerism is option A, 1-pentanol. Option B, 2-pentanol. Option C, 3-pentanol. Option D, 2-methyl-2-butanol. Option E, 2,2-dimethyl. Our answer is answer will be the answer. Okay, the molecule which exhibit optical isomerism.
Check the optical isomerism. We have to check the optical activity. How we will check optical activity of a molecule? So there are 3 conditions to check optical activity of a molecule. Condition 1, molecule should contain a chiral carbon atom. What is a chiral carbon atom? Chiral carbon atom means groups connected to carbon. There are 4 groups because the valency of carbon is 4. So 4 groups connected to carbon must be different. Okay. So carbon is connected to 4 different groups, then we will say it is a chiral carbon or asymmetric carbon. It's the first condition. There should be minimum 1 chiral carbon atom. Option 2, molecule does not possess any plane of symmetry. What is a plane of symmetry? When we cut a molecule into 2 equal half, if that 2 equal half becomes equal or identical, we will say that molecule possesses a plane of symmetry. What is the condition for optical activity? Molecule does not possess a plane of symmetry. That is, if we cut a molecule into 2 equal half, the 2 equal half must be different. That is the condition. Optical activity. Second condition. Then third condition, they should have non-superimposable mirror image. That is, molecule and its mirror image. How we will draw the mirror image of a molecule? Convert the left-sided group into right side and right-sided group into left. That is, left become right and right become left when we draw our mirror image of a molecule. And this original molecule and its mirror image become non-superimposable. That is, when we overlap the original molecule and mirror image, it won't be the same. We can't overlap each other. That means non-superimposable. It's the condition. Mirror image and the original molecule can't be superimposable. That is non-superimposable mirror image. If the condition 1, 2, 3, all 3 conditions are satisfied, then we can say the molecule is optically active. If any condition which does not satisfy one of the condition which is not satisfied, so our answer is answer B, 2-pentanol. Okay. What is the structure of all 3 conditions must be satisfied. Structure of 2-pentanol, that is, we have 5 carbons, 5 carbon atom in 2-pentanol. Pentanol, pent means 5 carbon atom. CC. 1, 2, 3, 4, 5. 5 carbon atom. In the second position, there is a alcohol OH group. Then it is known as 2-pentanol alcohol group in the second position. This is the structure of 2-pentanol. So we are going to check the optical activity. That is, we are going to check the three conditions. First condition, there should be one chiral carbon atom. Check for the first condition. This carbon is connected to hydrogen, CH3, OH and CH2, CH2, CH3. So all four groups connected to carbon are different. So contain a chiral carbon atom. Okay, contain a chiral carbon atom. First condition satisfied. Check for the second condition. Does not possess any plane of symmetry. The molecule does not possess. When we cut this molecule into through this plane, this half contain hydrogen, this half contain OH. Okay. So both are different. So does not possess any plane of symmetry. Then check for the superimposable condition. This is our molecule 3-pentanol, and how we will write down its mirror image. The left sided hydrogen become right side, and OH in the right side it is converted into left. This is its mirror image. When we overlap this mirror image with our original molecule, it won't be the same. So third condition is also satisfied. Have non-superimposable mirror image. Okay. So among the following four options, only 2-pentanol contain a chiral carbon atom. So you need not to check the three conditions. The first condition, chiral carbon atom. Check for the chiral carbon atom. Only the option B, 2-pentanol contain chiral carbon atom. Other remaining four molecule does not contain a chiral
Question
carbon
number
atom.
9.
So only
Which one of the following compound shows
cis-trans isomerism? Okay. Option A, pent 1-ene. Option B, but 2-ene. Option C, but 1-ene. Option D, propene. Option E, ethene. Which one show?
Answer is
cis-trans isomerism.
B.
This type of geometrical
So in order
isomerism.
to
Solve this question, you should know what are the conditions for cis-trans isomerism or geometrical isomerism. So conditions for cis-trans isomerism. First condition, there should be a double bond or restricted rotation. That means it contain a double bond or a cyclic group. Double bond and cyclic group have the restricted rotation. So molecule should contain a double bond, or the molecule will be a part of a cyclic group. Then only we can give cis-trans isomerism for that molecule. So first check for the double bond or for a cyclic group. Second condition, if there is a double bond, then two groups on each carbon must be different. Two groups connected to each carbon. Carbon will be a part of a double bond. So the remaining two groups will be present in a carbon. Okay, and that two group must be different. Then if the two groups connected to carbon are on the same side, then we call it as cis, and two groups on the carbon are opposite side, then we call it as different. So in this figure we can see this is cis because two groups are connected. It contain a double bond and one carbon contain two groups. Consider A and B. This carbon also contain two different groups A and B, and similar groups are on same side, we call it as cis. In the case of this, similar groups are on opposite side, so we call it as
in
trans.
our
Options, among the 5 options, only option B, that is 2-butene, will show cis-trans isomerism, because only 2-butene satisfy both condition 1 and condition 2. Condition 1, it contain a double bond or a cyclic ring, that is it contain a double bond. And in 2-butene, when we write down its structure, we can see two groups connected to carbon are different. One CH3 group, one hydrogen. Similarly, next carbon, one CH3 group, one hydrogen. Okay. Then when two CH3 groups are on same side, we call it as cis. When two CH3 groups are on opposite side, we call it as trans. So two conditions are satisfied, one double bond and two groups
Question
connected
number
to
10.
each double bond of carbon are
IUPAC name
different.
of
Okay.
CH3
Next,
thrice
only two butene
C
show cis
CH
trans isomerism.
double bond CH2. Option A 2,2-dimethyl but 3-ene. Option B 2,2-dimethyl pent 3-ene. Option C 3,3-dimethyl but 1-ene. Option D hex 1-ene. Option E 2,2-dimethyl hex 2-ene.
Answer is answer C. Okay, answer C. So when we check into this molecule, we can see
our molecule contain a double bond. So it is a alkene. It is an alkene. Okay. Also, when we number the molecule, when we given a UPSC name to a molecule, the lowest number should be given to our double bond.
So we are going to number in such a way that lowest number should be given to double bond. Also, I am going to split this CH3 thrice into CH3 single bond CH2 twice. Okay. So consider our molecule. It contain, when we notice our molecule, it contain 4 carbons in the main chain. We split this CH3
Thrice into CH3 single bond CH2 twice.
carbon, which means the third carbon contain 2 methyl group as a branches. Then this CH3 group belong to the carbon main chain. Okay, so total there are 4 carbons in the carbon main chain and it is a alkene. So double bond in the first carbon position. So what will be its name? 4 carbon. This is a double bond in the first position. So it is but 1-ene. And there are 2 branches in the third position. That is one CH3 group and second CH3 group connected to the same third carbon. So 3,3-dimethyl but 1-ene. It is the name of our compound. Okay.
Question number 11.
So
Which one of the following undergoes
answer C.
iodoform test? Option A propanol, option B ethanol, option C benzophenol, option D benzaldehyde, option E phenol. Answer is answer B. How we will reach to this answer? That is, a molecule undergo iodoform reaction must contain a alpha methyl group. What is a alpha methyl group? That is C double bond O CH3 group. Okay, C double bond O CH3 group is known as alpha methyl group. If a molecule undergo iodoform test, then that molecule should contain this group, alpha methyl group. So in our question, in the options, only ethanol contain a alpha methyl group. That is, ethanol with molecular structural formula CH3C double bond OH. This is the structural formula for ethanol. Ethanol means 2 carbons and it is a aldehyde. So 2 carbons with aldehyde group CHO, C double bond OH. CH3C double bond OH is the structure for ethanol. So only ethanol contain this alpha methyl group. So only ethanol undergo iodoform test. So remember, for iodoform reaction there should be an alpha methyl group. Question number 12. Isomers which can be interconverted through rotation about carbon-carbon single bond are option A diastereomers, option B enantiomers, option C conformers, option D chain isomers, option E position isomers. Okay, what is the answer? Answer is option C. Okay, option C. That is conformers. What are conformers? Conformers are the molecules having same molecular formula and same structural formula but different in their 3-dimensional arrangement. It's a type of stereoisomer and this 3-dimensional arrangement is due to or it's result from rotation of groups about carbon-carbon single bond. So isomers are obtained from rotation of groups about carbon-carbon single bond. So answer is option C,
conformers. You should know what is the definition of conformers. Only difference in three-dimensional arrangement, and that is arise from rotation of group about carbon-carbon. Question number 13. Half-life period of first order reaction having rate constant K is equal to 0.231 into 10 raised to minus 10 second inverse will be. What is the half-life period? Okay, rate constant is given. Option A 32 into 10 raised to 10 second. Option B 2 into 10 raised to 10 second. Option C 3 into 10 raised to 10 second. Option D 2 into 10 raised to minus 10 second. Option E 3 into 10 raised to minus 12 second. What will be the answer? Our answer is answer C. How we will reach into this answer? That is, rate constant for a first order reaction is K is equal to 2.303 divided by 2 log initial concentration of the substance AI divided by final concentration of the substance AF. So AI is the initial concentration, AF is the final concentration, and T is the time taken. Okay. So when we consider half-life, that is T is considered as half-life. So half-life is the time taken for the concentration of a substance to become half. When concentration become half, then the time taken is known as half-life period. So initial concentration is AI, and during half-life time is considered, then final concentration AF become equal to initial concentration divided by 2. Okay, so AF equal to AI divided by 2. Substitute this into this equation by considering half-life time. So K become equal to 2.303 divided by T half. We are considering half-life. Log initial concentration AI divided by final concentration AI by 2, which is 2AI by AI. So this AI get cancelled. So we have log 2. Substitute the value of log 2 into 2.303. So final equation will be K is equal to 0.693 divided by T half. Okay, T half is the half-life, K is the rate constant for first order reaction. Then from this we will get equation for T half, that is half-life period. T half is equal to 0.693 divided by K, where K is the rate constant for first order reaction. The value of K is already given in our question, which is 0.231 into 10 raised to minus 10. So substitute this value into the equation for half-life period for a first order reaction, that is 0.693 divided by K. So we will get the answer 3 into 10 raised to 10 question. That is number answer 14. Is option C. Consider the following electrolytic cell. We have 3 type of cell, and the question is the cell EMF of the above cells are 1, 2, 3 cells are E1, E2 and E3 respectively. Which one of the following is a true statement? That is the question. We have 5 options. Option A, B, C, D and E. Which one is the correct statement? True statement. So you should know it is the electrochemical or electrolytic cell representation. In this cell representation, the left hand side, in the electrochemical cell representation, the left hand side we will always represent anode. So left handed side in cell 1, 2, 3, this left handed side part will be the anodic part, and right handed side will be the cathodic part. So M solid dip in Mn2 plus electrolyte is our anode, and X dip in X2 plus electrolyte is our cathode. Okay, so what will be the correct condition? So for that we have to measure the EMF answer values. Will be option D. How we will reach into this answer? I already mentioned in an electrochemical cell representation, in our left hand side we will have anode, and in our right hand side we will have cathode. Okay, so we know that anode is the electrode where oxidation take place. What is oxidation? Removal of electron. And cathode is the electrode where reduction take place. What is reduction? That is addition of electron. So
what will be the anodic reaction? Left hand side we have anode, M solid, dip in Mn plus. So anode will undergo oxidation, removal of electrons. So reaction will be M gives M2 plus 2 electron. And cathode is in our right hand side. So cathode is X dip in X2 plus. And cathode will undergo reduction. Reduction is addition of electron. So X2 plus 2 electrons are added. And in anode, electrons are removed. Okay. So cathode is X2 plus 2 electron gives X. It's the anodic and cathodic reaction. From this, we can write down the overall cell equation by adding anode and cathode equation. When we add anode and cathode equation, the common terms in the opposite side get cancelled. So here we have 2 electron, here also we have 2 electron. 2 electron is our common term. They get cancelled. So overall equation becomes M plus X2 plus gives M2 plus X. This is our overall equation. From this overall equation, we have Nernst equation for a cell. What is equation for Nernst equation for a cell? Nernst equation for a cell is equal to E cell is equal to E0 cell plus 0.0591 by N log reactant side by product side. If we are considering here a plus form, then we have to write log reactant by product side. That is, reactant side is M plus X2 plus. Product side is M2 plus X. Also, the concentration of pure metal will be always equal to 1. So, concentration of pure metal M and pure metal X become 1. So, what will be the Nernst equation for this equation? Considering pure metal concentration M and X equal to 1, what will be the concentration? That is, E cell is equal to E0 cell plus 0.0591 by N log reactant side. Only consider X2 plus. Concentration of M is 1. So, reactant side X2 plus divided by M2 plus. Okay. This is the concentration. Cell potential. Nernst equation for a cell. Then, we are going to substitute the values. Already in the Nernst equation representation, their concentrations are given in the bracket. We can see X2 plus aqueous comma its concentration. Similarly, M2 plus aqueous its concentration. Its concentration values are given in the bracket. So we can select in each case, 1, 2, 3 case, we can select X2 plus and Ml2 plus from the bracket and find E cell. And finally, we will find that in the case D, it is the correct answer. E3 greater than E2 greater than E1. In the case of E2, the concentration of X2 plus and M2 plus, which is equal to 0.1. So log 0.1 divided by 0.1. So log 1, that is this logarithmic term becomes log 1 value 0. So this term cancel. E cell is equal to E0 cell. If we substitute the values for third cell type E3, in order to calculate E3, when we substitute X2 plus divided by M2 plus, log will be a logarithmic value will be a positive value. So E cell will equal to E0 cell plus a value. That is, E cell is greater than E0 cell. In the case of E1, here when we substitute X2 plus and M2 plus is a high value. Okay. So when we take its logarithmic value, its value become a negative. Its value become negative. So E cell is equal to E0 cell minus a term, which means E cell is less than E0 cell. So in E1, E cell is less than E0 cell because logarithmic value becomes a negative. In second type cell E2, E cell equal to E0 cell. Okay, because logarithmic term equal to 0. Log 1 equal to 0. In E3, E cell is greater than E0 cell because logarithmic value is a positive. So E cell equal to E0 cell plus a value. E cell is greater than E0 cell. So order will be E3 is greater than E2 because E cell become equal to E0 cell. Then comes E1 because E cell is less than E0 cell in case of E1. When we substitute its value in the main equation, logarithmic term equation, this part, that is the concentration part. The concentration is given in the bracket. In each case, concentration of X2 plus and M2 plus you can see in the bracket, aqueous comma bracket. Okay, concentration, substitute the values, you will find this answer. E3
Question
greater
number
than E2
15.
greater than E1.
Correct decreasing order of reactivity for a given alkyl, that is R group, in both SN1 and SN2 reaction mechanism is option A, Ri greater than Rbr greater than Rcl greater than Rf. Option B, Ri greater than Rcl greater than Rbr greater than Rf. Option C, Rf greater than Rcl greater than Rbr greater than Ri. Option D, Rf greater than Ri greater than Rcl greater than Rbr. Option E, Rbr greater than Ri greater than Rf greater than Rcl. So what will be the answer? Reactivity order of alkyl group both in SN1 and SN2 reaction. Our answer is answer A. How we will reach into this answer? We know that both for SN1 and SN2 reaction, the reactivity order of alkyl halide is iodine greater than bromine greater than chlorine greater than fluorine. If the stability of carbocation order in SN2 reaction is primary greater than secondary greater than tertiary, and for SN1 reaction it is tertiary greater than secondary. In this video
greater
also
than primary.
we discussed
But
15
alkyl
questions
halide
from
reactivity
previous
order is
KEAM
same
question paper.
both in SN1
Please refer
and
this.
SN2 reaction.
This
That
will
is
help you in your
iodine
KEAM preparation.
reactivity is
Once again,
greater
thank you
than
for watching
bromine,
us
then chlorine, then
and
fluorine.
all the
So
best
answer
for your
A
exam.